ancient symbol of enduring life. It is the modern symbol for copper, one of the most useful, versatile, and durable of all the metals. Since the dawn of civilization, copper has been an essential element in the technological advance of mankind. Its value results from its high electrical and heat conductivity, its resistance to corrosion, and its ductility and malleability, which allow it to be drawn and formed without breaking. Copper is number 29 in the periodic table of elements. Its physical characteristics, so well known for thousands of years, are now recognized as manifestations of its atomic structure. The copper atom contains 29 protons in its nucleus, surrounded by 29 electrons arranged in 4 shells. 14 of these atoms, bound tightly together in a face-centered cube, form a unit cell, which contains all the characteristics of the metal. A large number of these unit cells, joined by sharing atoms, form the copper crystal. The crystals, packed closely together, form grains, and grains, not quite so closely packed, become the metal so prized for its usefulness. It is this structure of copper which gives rise to its physical properties. Makes it malleable, enables it to conduct heat rapidly, allows it to resist corrosion, permits it to be drawn, and enables it to conduct electricity efficiently. But these are the properties of pure copper, and pure copper in any significant quantity does not occur in nature. The ores of this important metal contain copper in chemical bond with iron, sulfur, and other elements. Exploration for copper-bearing ores is a continuing activity extending into the most remote sections of the world. Wherever copper deposits are found, they are studied carefully to determine whether mining is justified. Copper occurrences of commercial grade have been found in many parts of the world. One of the principal copper-producing areas is the southwestern part of the United States. Differences in depth and in the geological formations where these deposits occur have brought about 2 altogether different kinds of mining: open pit and underground. Various mining methods are used in underground mines. Here, where ore bodies are scattered far below the surface, access to the ore is gained by drifting out from the shaft in different directions and on many levels. ore buried half a mile deep is first broken by drilling and blasting. Gravity helps feed the broken ore through chutes into cars on a lower level. Skips hoist the ore up the shaft to the surface for treatment. The giant open pit mine provides an economical method of recovering low-grade ore from large bodies closer to the surface. In the development of the pit, immense quantities of material must be removed. More than half of this is waste rock. On these levels or benches, mining operations change the shape of the land, creating huge canyons where mountains once stood. To break the rock, thousands of pounds of explosives may be used in a single blast. Only part of the broken rock contains copper in commercial quantities. This is marked as ore. rock without enough copper to justify treatment is identified as waste, transported from the pit, and discarded. The ore now begins its long journey through the complex processes from which pure copper will eventually emerge. The copper content of the ore removed from the pit is only about 1%. The three major steps in extracting this copper are concentrating, smelting, and refining. Concentrating is accomplished by floating the copper-bearing minerals away from the rest of the material. First, the ore is crushed and ground in water and mixed with oils and reagents which adhere to the shiny copper sulfide particles. Then, in the flotation cells, air bubbles collect the coated mineral particles and float them to the surface, forming the concentrate. The dried concentrate contains about 30% copper. To prepare the ore for flotation, it is first passed through a series of crushers. Then ball mills pulverize the ore. Classifiers pass the properly sized material on to the flotation cells. Here, the rock particles, called tailings, remain in suspension, while the copper minerals are floated to the top. The tailings from the flotation cells are sent to thickeners to recover most of the water. Then they are deposited on vast tailings dams. From every 100 tons of ore treated, 96 tons of material are discarded as tailings. The concentrate is now upgraded by further grinding and flotation. After most of the water is removed on filter drums, the concentrate is ready for smelting. In addition to copper, this 30% concentrate contains iron and sulfur in chemical combination. Heat alone will not break these chemical bonds. To separate the iron, silica rock is added. The iron combines with silica to form a slag and is drawn off. To remove the sulfur, air is introduced. The sulfur reacts with the oxygen and goes out as a gas. To remove the excess oxygen, which remains, reformed natural gas containing carbon monoxide and hydrogen is injected. This process results in copper more than 99% pure. In the smelter, the concentrate is charged into the reverberatory furnace. nearly 3,000 degrees, it is reduced to a molten pool. Some of the iron floats to the top as slag, and the mat containing copper, sulfur, and the remaining iron settles to the bottom. Periodically, the slag is withdrawn from the reverberatory furnace and discarded. The copper-bearing mat, which has settled to the bottom of the reverberatory furnace, is withdrawn and transferred to converters. In the converter, the remaining iron reacts with silica rock to form converter slag. Since this slag still contains some copper, it is skimmed and returned to the reverberatory furnace. Air is introduced to the converter to oxidize and burn off the sulfur. Frequent punching keeps the air ducts open. The copper from the converter still contains oxygen. This is removed by further treatment in the anode furnace. Here, the oxygen reacting with reformed natural gas goes off as carbon dioxide and steam. Now about 99 6/10% pure, the copper is poured into the molds of the casting wheel to make the anode forms used in refining. The remaining impurities, including gold and silver, total only about 0.4%. These are removed by electrolysis. In the refining process, the copper anodes are submerged with cathodes of pure copper in a solution containing copper sulfate and sulfuric acid. As electric current passes through the cell, the anode is gradually etched away, and pure copper flows with the current and is deposited on the cathode. In the refinery, acres of such cells accomplish the final electrolytic purification. The anodes are lowered into the tanks and carefully spaced to avoid short circuits. The starting sheets or cathodes of pure copper are made in the refinery. These thin sheets are interleaved with the anodes, and the electrolysis begins. It takes about 14 days for the copper to be deposited on the cathode. At last, the long and intricate process of producing pure copper is complete. cathodes are then melted down and recast into the shapes required for fabrication. Now copper's valuable properties become apparent. Alloyed with zinc to form brass, alloyed with tin to form bronze, and in its pure form, copper is fabricated into innumerable useful products. Paradoxically, after all the effort to find and recover the metal, many of its uses require that it be concealed again and perform its work unseen. Hidden behind walls and panels. Buried in the ground and under the sea. Covered by housings and hoods, hidden sometimes even in the deep reaches of space. Copper is the key to power and communication, serving unseen in all things electric or electronic. But copper is not always hidden. Its beauty has been treasured through the ages. Its physical properties reflected in countless attractive, practical, and durable products. And its adaptability utilized time and time again in the changing world around us. The uses of copper are many, its value to mankind untold. Yet some of its secrets still await discovery. By experimenting with extremes of temperature, developing and testing new alloys, studying the mechanisms of chemical change, and in countless other ways, research is constantly increasing the usefulness of copper. Copper helped man take the first faltering steps to improve his life on Earth. It is with him today as he reaches out toward the stars. This metal, born in antiquity, is as modern as tomorrow. Copper, truly the oldest modern metal.